Yeah, all of you can hear me? Can all of you hear me?
Yes, sir.
Fine. So, uh, sharing my screen. Can you see my screen? I hope all of you can see my screen.
Yes, sir.
Fine. Now, let us see here. Design of RCC slab supported on all sides for IRC class A loads. The last numerical was for IRC class AA loads. So this one will be IRC class A load. So yesterday we discussed the data is given, then the permissible stress and stresses are given. Now we know, if you see the figure, first of all, what happens? First of all, in this numerical, if you, hello, hello, am I audible? Hello, is my audio clear to everyone? Okay, yes.
Yes, sir.
Okay. So first of all, in this numerical, in the figure 3.19, if you can see here, the IRC class A loading pattern. That means the two wheels will be like this, W1 and W2. Okay, so this is the slab. Dimensions of the slab is given. Now, if you can see here, this IRC class A loading pattern, this width, this 0.66, 0.41, 0.995, everything you will be able to find from the IRC class A load diagram. Now, in this figure, first of all, if you see the W1 load is symmetrical, that means it is in between. Initially. But this W2 load is unsymmetrical. Why unsymmetrical? Because it is in one part of the slab. Now, for this only, we will be considering an imaginary load W2 here on the other side of the slab. And then eventually we will find out for the whole slab in this manner. Okay. Now, let us start doing the numerical. First of all, you have to find out the bending moments due to W1. So this W1, for finding out the bending moment, you have to look at the piegauds curve U equal to and V equal to. So U and V values you have to find out. Just like we found out in while doing the numerical for piegauds curve. So this U and V initially you find out. Then after finding out U and V, look, U will be 0.5 plus 2 into 0.08. Then V will be 0.25 plus 2 into 0.08. I hope you know why, how you find U and V. Now, from this we will be getting U equal to 0.66 meter and V equal to 0.41 meter. Now, for your convenience purpose, you can just remember the small u and small v values for IRC class A loading, because the dimension of the wheel always remain the same. That is why you can just remember. Now, U by V ratio and V by L ratio you find out. After finding out U by V and V by L, you find out k equal to b by l. So please start noting it down. Once you are done, please let me know. Please start noting down this numerical. Please let me know once you are done noting this down. Yeah? So now after this, once you find out k and u and v, we have to find out small m1 and small m2. Now then ma and mb. Okay. So just try to find out and tell me the answers what you have got for this purpose. Then I will be sure that you are doing the numerical. Once you are done finding out q, find small m1, small m2, then capital ml and capital M. Those who are done solving the ML and capital ML and capital MB, just write down in the chat box the answers. So here is the diagram. Just have a look at it. 3.19 for the first case. Very good. I got only one answer. What about the other people? Can anyone give the other answers? Other people also give the answers. Very good. Okay, seems like no one is interested except one. Okay, let's go to the next part. Now, you find out the M1 and M2. Very good, okay. You got the correct answer. Now, once we find out capital M1 and M2, so this is for the load W1. Now, let us find W2 bending moment due to unsymmetrical load W2. Now, if you see here, the W2 was placed here, right? Now, so in order to balance this, we place the W2 in another side also. Now, we remove this W1 and we place this W2 in other side also. Okay. Now, if you place this W2 in other side, then this thing will be balanced, right? And then it will be symmetrical. Now, if you find out W2 here, now the thing is that while finding out this W2, U by B will remain same. Okay. As if you see the figure, this is U. This is U, right? This is U. So U by B, it will remain same. But since we have put the load W2 in this side also, so the distance between these two loads, this should be small v. Okay. So the difference here is only this one. So small v by L. So 2.81 divided by 4. So this is how we'll find out small v by L. Now we find out K is then K, we find out the K value, and then similarly we find out MB and ML. Now there comes the next step. Now look, you just try to learn the concept behind it. Okay. So now what happens is that we'll have to now look MB and ML we got it, right? MB and ML we got it. Now we'll have to subtract one part. Which part will be subtracted? Look, now we found out for this part. That means what? For this whole part we found out, right? Now this red part we found out. Now what will happen? This blue part, this will be the extra part, right? That is why we have to subtract this part from this whole part, right? So if you minus 2.81 minus 0.41 twice, because this is also here 0.41, then you will get what? 1.99. So in the third case, okay, in the third case, the U by B or the U value will remain as same as 0.66, but the V value will be changed to 1.99. Okay, and then we'll find out again MB and ML. Is it clear? I hope this is clear for every one of you. Can someone please respond? Can someone please respond?
Sir, please can you explain the third case? 0.99.
Okay, good. So look, the first case is clear. Now the second case, what happens? We considered for this whole part, that is 2.81. Like we put another W2 load here, so as to make this W2 symmetrical, because this is unsymmetrical, right? So if we have to make this W2 symmetrical now, look, we found out the moments MB and ML, right? So ML we found out for this whole part, isn't it? Isn't it? But what we need? We need the ML only for this part and this part. because this the part which is in between, this is not needed. The part that is shaded in green is not needed, right? So if this part is not needed, then what will happen? We'll have to subtract this part and the dimension. Hmm, and the dimension of this part, that means this one and this one, you'll be getting this how? If you subtract 2.81 minus this W2 this part and this W2 this part, that means what? It will be 2.81 minus what? 0.41 minus 0.41. It turns out to be how much? 1.99. Is it clear now?
Yes, sir, it's clear now.
So after that, for this 1.99 part, in the third case, you'll have to find out MB and ML again, right? So you'll have to find out MB and ML again. So for after finding out this MB and ML, okay, what you'll have to do is you have to you will be getting another value of MB and ML here. You will be getting another value of MB and ML here. Now, okay, now what happens is that you will have to subtract this MB, this one. This is the MB for third case, that is figure 3, and this is the MB for figure 2. Okay, that means for this part combined, this MB will get, and you will get another ML here also, right? And these will be bigger since the dimensions are bigger in this case. So the MB and ML will be bigger in this case, and the MB and ML will be smaller in this case, because this is the only, this figure 3 is only what? Figure 3 is somewhat like this. Wait, I'm going to show you. In figure 3, what happens is that the W2 load will be here. So this is just that between part, right? So this will be less. So you found out the MB and ML for this part and MB and ML for this whole part. Now you have to subtract the MB of this part with the MB of this part, and then ML of this part with the ML of this part. And then eventually what will happen? You will be getting like this. Now look, there is 0.5 here. Can you tell me why 0.5 is there? I hope this is clear, this subtraction part. Can you tell me why this 0.5 is there? This 0.5 is actually for this W2 is what we consider under W2 to make it symmetrical, right? But we have to find out only for one W2. That is why we divided it by 2 after making it symmetrical. That's it. Okay. Now the total live load moments, this continuity and impact factor. These are the two factors that are to be considered for this type of design in IRC class A loading. Okay. So 1.25 and 0.8 are continuity and impact factor. That is why we added the total MB. Total MB means what? For W1 and for W2. For ML for W1 and W2. And then we found out the moments. Fine. Now we have to find out the dead weight of slab. Now for finding out the dead weight of slab, the thickness of the slab is 0.2 meter. So 0.2 into 24. 24 is the unit weight of concrete. Okay. Then dead weight of wearing coat. The wearing coat is 22 is the unit weight and 0.08 is the thickness. So we found out the total dead load. Now moments due to dead load. This can be computed by considering the U by V as 1. That means for unit dimensions, because in this for live for live load we have that dimensions of the wheels, but for dead loads we can consider the slab as unit dimensions. That is a U by V equal to 1 and V by L equal to 1, and then we find out using those K, find out K, then small m1 m2 and mb and ml. Okay. Then look here, in this numerical, after finding out MB and ML, the continuity is only taken into consideration, not the impact factor. Why? Why impact factor is not considered? Because look, dead load means what? Dead load is the weight of the slab, right? But in live load, when the wheel suddenly falls on the bridge slab, there will be certain impact. But in case of dead load, there won't be any any worth, or it will not be worth to consider the impact factor. That is why we are not considering the impact factor. Okay. So now after finding out the dead load bending moments, we find out the total design moments. Total design moments will be what? For MB it will be for dead load and live load, and for ML it will be dead load and live load again. Now for designing the slab, we find out the effective depth, then area of steel for MB, and then effective depth and area of slab for ML. That's it. Okay. So this is how we will be computing this kind of numerical. I'll be sharing the two numericals PDF with you guys. Okay. With Michael and all. So you guys please circulate in your class groups.